Now that we've got a better sense of radian measure and where it comes from, we can use this for some common formulas that you probably learned back in geometry. Now, the difference between what we're doing in this particular video and what you did in geometry is that when you learned how to take the measurement of an arc length, or if you learned how to find the area of a sector, what you were using as a reference at that point was called the central angle. And so the arc length and the area of the sector were always based off of percentages of the circle given as a result of the degree measurement of the central angle. And so now we can take this radian measure and have a similar attitude towards it. It's still a percentage of the entire circumference. The sector is still a percentage of the entire area, but now we're going to relate it to our radian measure, and we could derive a couple of formulas from this. And so I'm not going to take you through the way that we derive these formulas, but you can quickly see that arc length is linked back to the radian measure, which is a ratio of the arc length to the actual radius of the given circle. And so if we're given the radian measure, we can work our way back into arc length pretty simply from that. With area, we can also have the area if we know the radius and the given radian measure of the central angle. And so once we know that information, we can quickly come up with the area of the sector. Now, keep in mind, you will run across a situation where sometimes they may give you the central angle in terms of degrees. If you want to use these two formulas, you must convert that to radian measure first. These formulas are given to you in terms of radians. So just be very careful about that. So as you look at sample problem number 5 and you try to figure out the arc length and the area of that sector, make sure that all the given parts are as you need them. So go ahead and give that a shot at this point. Okay, and so as we look at this problem, it says to find the arc length and the area of the sector. We were given a radius of 9 centimeters, and we were given a central angle of 60 degrees. And so the first thing we have to do is understand what that is in terms of radians. And you remember 60 degrees is the same thing as pi over 3. So if I'm going to find my arc length, I'm going to use my arc length formula. I'm going to take my radian measure, which is 9 centimeters, and I'm going to multiply it times my central angle. And what this gives me is a value of 3 pi radians. Now, centimeters. I can take this and I can also put it into my calculator if you like, and you can get a value of 9.42. And so this is in terms of centimeters, and since the radius is given in terms of centimeters as well. And so either one of these answers is acceptable depending on what the directions ask you to do. Now, the area has a little bit more calculations involved, but pretty straightforward since we are giving you the formula of r squared, so that's 9 squared times the central angle, which in this case is pi over 3 again, and we can just simply work our calculations. And if you want to punt all of this into your calculator at once, you're more than welcome. You don't have to work out every single step such as I am doing here, where we get 27 pi over 2, and of course that's centimeters squared. Most probably what you would see is this answer in terms of decimals, which would be 42.4 centimeters squared. So those are two basic examples of obtaining arc length and area when you have a central angle given to you and using it in terms of radians.